Yeah, I kind of mentioned this yesterday to some of you guys about Soviet Harvard style science. And what it's basically is saying that in consciousness, especially with respect to mind and also physical relationship, basically we don't know. And easiest kind of aptitude to take is this, illusionism or eliminatism or, behaviorism and things like that, where what you don't see is not there, meaning this is a consciousness or qualia, and then what he doesn't understand doesn't exist. So if you don't understand, then you just, ignore or explain away. And this is a kind of the attitude I don't think you want to take, at least for during the summer school. And that's remark from Nassim Taleb. All right. And then another thing, I also thought that it would be interesting to, or useful for you guys to also, organize your thought is that distinction between methodology, epistemology, and ontology. Many of the things that we talk, I try to be clear about this in my talk, but even Matthew's talk and so Christop's talk, there are bits and pieces about methodology, about epistemology, or about ontology, or any combination of these things. Methodology is about really method, right? Like in the case I'm going to talk right now, structural Qualia structure is mainly kind of methodology. How to measure Qualia, for example. And epistemology is how can we know, how can we understand about other people's experience. That's a sort of that, how do we know kind of thing, knowable facts thing that, some Matteo and Christoph also talked about. And then ontology is how it is. So what is the mechanism or what is the sort of underlying nature of the qualia and things like that. And these three things are interconnected in some way, but during the discussion, especially small group discussion, it will be very useful to distinguish what kind of aspect you're talking about, because sometimes passing discussion goes about this domain, and also you sometimes unconsciously take just methodology, but becoming implicitly ontologically committing to something. That is a very, very frequent kind of behaviorism. I know that we can only analyze or take the measure the behavior or measure the response and things like that. Therefore, I'll take the methodological behaviorism, but at the same time, implicitly, many people just become the ontologically also behavioristic. So you need to be conscious about this. And then structuralism is the things that also there are lots of discussion about this right now, and many of the even the philosophical literature is confused about this. Actually, they claim that we are talking about methodology, but then starts to commit to ontology, and then by the end of the paper, you don't know what we are talking about. Anyway. So with that premise, I'll just start my talk. I upload my slide, and then this is a link to this, and also the paper summary about the Qualia Structure project is over there. And the outline is I'll just give a brief background on this Qualia Structure Paradigm, and then I'll give a more empirical kind of grounded research this time, because so far it's been quite heavily theoretical or philosophical, right? And then I also try to introduce a little bit of the mathematical stuff without going to computational side, which is Masarumi's talk after this. So the background. By qualia, because Christopher Matteo didn't really explicitly define it, I'll just say phenomenal consciousness, the subjective experience, contents of consciousness, qualitative aspects of consciousness, feelings, what it feels like. All of this we'll talk as a qualia for this talk, and also this summer school probably. And then the distinction will be non-qualia. And anything you don't have experience directly. Okay, this is already kind of, probably some of you need to disentangle your ontological commitment from this kind of definition. Because if you want, the moment you say that, oh, I have a fear, and because there is an amygdala activation, there's a fear, you are already committing to this so-called ontological, mind-body identity or mind-brain identity hypothesis already. But what I want to emphasize here is that anything that you directly do not experience is not qualia. So in this case, amygdala activation or fear response. That's not the fear, right? Okay, fear response that you have in the skin could be a part of your qualia if you experience it. But if it's not, then that's just a response. And for the moment, we treat it as non-qualia. Qualia is everything that you experience, basically, which could or could not be introspectable with the discussion there. And then one important or useful distinction in qualia discussion is about narrow versus broad distinction. So that when you see some kind of sunset like this, we could talk about narrow aspects of qualia, such as the redness of the red or cycleness of this shape of the sun, or broader. Broadest would be one moment of the experience, including all the sorts of the modalities with or without attention and so on. And interestingly, this one is actually already starting to come to the category theoretical component aspect of the reality. What I mean is that the more abstract and also focusing on one aspect of things, narrower, then that can be generalized, right? But the less you restrict what you're talking about, and then the moment of experience right now, it's so unique that you don't have any kind of duplication. So the more you want to be more abstract and mathematically precise, you need to be abstract and then focusing on narrower things to apply many things. But then you also lose the kind of the contact with the actual reality, broad reality. So this, on one side, this phenomenal narrow to broad, and also mathematical sort of generalization to concrete kind of example. That's something so-called contravariant factorial relationship, and also sheaf theory. I'll briefly talk about. And I also yes. Same. Same. But experience is sometimes. No, because experience is sometimes, according to some people, includes really the memory. That's the confusing part. But by default, I think experience is probably about experience now. And experience of the past is also included in the current, right? Your experience of the past is current experience of the memory. And of a future plan is a current experience or experience of the future. So in that sense, experience and the qualia is exactly the same. But when you start to talk about this, I had an experience of, having a drug in the past, as if it is an objective fact, regardless of your experience, then it starts to, cause some kind of confusion. Now, yes, now here. That's the broad qualia. All right? According to this framework, and I could be wrong, by the way. I may also change my mind, in 3 days, 3 months, 3 years. And I also list a bunch of the questions, but I think that's probably better to just go through everything and then I'll start to talk about these questions. Yeah. So here, I don't know all the qualia theories around, so I can't really say I answer to your question. Yeah. Yeah, maybe. Okay. Okay. So that actually comes to a couple of slides later, but this intrinsicality of qualia is something you might want to discuss in the afternoon, actually. That's my answer for now, okay? So I'll go back to this kind of question later, but I'll just skip for now. So as already Christoph attacked or sort of, criticized Dennett type, idea, qualia has been considered as non-scientific for a long time, at least, by many prominent philosophers. And Dennett's, this article, so-called the Quining qualia, has been probably very, influential either explicitly or implicitly. And what Dennett says is that qualia is ineffable, meaning that you cannot describe above and beyond what is red, oh, that's red, or wine red like thing or whatever. And enigmatic, that's the sort of the functionary, we don't know what it is for, and the privateness. You can't directly share the experience, and also this intrinsicality. We'll talk later. Yes. Yes. And therefore, it's not a useful scientific concept. So that's the thing that I also wanted to mention about this, right? Then it is exactly this, Harvard Soviet. Although he was, Tufts, it's almost the same location. He doesn't, he kind of accepts that, he has a pain, probably, if you really, inquire him, like Christoph actually, pushed him. So you don't need anesthesia for your surgery? He said, no, I need it. Why? Because he has pain. But academically, because he wanted to be very kind of perfect or sort of, trying to be more kind of, knowledgeable, probably, I don't know. He doesn't want to admit what he don't know, right? And then the easiest move is to deny the existence of what you don't know. Yeah, but that's really not him only, but many people right now, especially. And then, but the main research is actually, even Christoph didn't talk about the qualia Q word, right? By the way, when I joined his lab, first thing he said that consciousness, no, C word, don't talk about it. He allowed us to talk about awareness, attention, but didn't allow consciousness, C word. Now he's okay with the C word, but not Q word yet. But I try to always push the boundary. So qualia structure, okay? So as a result, many of the empirical neural correlates kind of project has been, in fact, focusing on the very narrow kind of, behavioral response, mostly binary response, right? Even the adversarial collaboration is always about in binary, whether you see it or not, or did you see A or B kind of thing. And many gradient, but it's basically binary response categorization. But this, I think, is one of the reasons why it has been that there is an explosion of consciousness theories that Christoph mentioned. So initially, Tim Bain and Anil Seth identified roughly like 40 neurobiological theories of consciousness, and then Kuhn, he's very good at interviewing many people, including Christoph and so on. He counted 280 theories for including religious and also kind of spiritual kind of tradition and also philosophical traditions. But it's not that it's just there making it for free. Most of them actually care about some of the empirical research, but the empirical research is so concentrated on this kind of binary stuff, right? Presence or absence and things like that. I respect the IIT kind of approach of starting from this fundamental presence absence binary kind of thing or gradual thing, but that's still too weak to constraint theories, right? And therefore, we are approaching this problem from the structure perspective. And my sense of this qualia approach, scientific approach, the qualia requires structure approach, and so IIT type structure approach. And also, I think both of them are not enough at all. It's somebody said that to get there, we need to shoot for the moon, and then we are probably fighting around here, right? But I thought that with probably Zifan, I thought that the IIT or Qualia structure is probably founded on the mathematical foundation. So we are, I hope, building something on top of the land, probably. But other theories based on the intuition or sort of folk theories probably riding on the waves. So sometimes they feel like they are going high, but it's probably not possible to reach the moon, right? So this is the Qualia structure project, and then at least we have funding until 28. And this is our Japanese colleagues and PIs hired here and the Masami there. And we are combining psychophysics, mathematics, phenomenology, philosophy. I was actually surprised that you knew about Nishida, the Japanese philosopher, and also Hayato may be talking about this kind of relationship with mathematics, and also cognitive development, neuroimaging, but it's very relatively small, and also linguistic or symbol the emergence type stuff, including the Peirce, the philosopher in the early 20th century in US. His idea is probably kind of related, and so on. Okay, and then as I said, the structure approach is what unites everybody. And here we are, in this nice island with lots of faculty. And we are probably going to do this, not in 2026, probably 27 in Okinawa or so again. So here comes some of you already who read my paper and so on is know about this, but I go a little bit about this. The problem of the qualia and also giving up of the neurophysiologist or behaviorism as a binary response is partly stemming from the difficulty in characterizing qualia of redness itself, right? Above and beyond, it is red or it's similar to something, you cannot do anything. But this kind of situation has arisen in many different areas of the science. And many that founder probably of this idea is this or two, who was a founding father of the modern, linguistics. And he basically said that, meaning of the words are there in the relation to each other. And as long as we can clarify the, relation to the words, then we can understand the meaning of the words. And also, Hayato pointed out to me that the Indian philosopher Dignaga and Apoha theory, which is very old kind of idea in Indian logic, also said something like that. You cannot define the meaning of the words through its pointing to this is a meaning. But what it is not about that is, what we can do in terms of the meaning definition. And that's pretty much the same idea. Right. Above and beyond this very concrete thing. At the bottom, broad qualia, as you go above, it's all about, relations, at least. And then black hole is also not possible to observe, but, you can measure the interaction and the infinity in mass and personality. I'll just skip this kind of, example, but, is all through this relationship. And then the Yoneda lemma in category theory, that's the most important inspiration for us. So usually I skip this equation, but I'll spend a minute here. So home is so-called home something here. So up to here, it's called a home functor. Okay, it's a relationship between A to this part is sort of wild card kind of character to every object in that particular category. And home A something or anything is a collection of the relationships between A and something. It's not usually only one. But by default, A and let's say B could have many relationships. It's like, from here to mainland, there's only one way to go by boat. But once you get there to Bologna, you have multiple ways to get there, right? So that's the kind of the home set. So this is a set of the pathway, okay? And then you now have to think about home of this kind of object, lots of relationship between A and everything, to another functor. So that's a very complex, sort of abstract, second order or third order kind of relationship. That is isomorphic. This is isomorphic, right? Our kind of, yeah. To the functor sending A to, sort of the codomain of A. So it's very complex, and you don't need to understand this, but the idea of this home functor, thinking about one, it's something's relationship to everything else is very important. And then eventually, from this Yoneda lemma, what you gain is one of the corollary is that if the relationship between A and its surrounding, all the relationship between the A and everything in this particular category is the same as B and its relationship with everything else in this category, then A and B must be isomorphic. So that's the category theoretical definition of this, Yoneda lemma. And because of this, we were kind of inspired to characterize qualia or experience can be also be done in the same way, basically. I don't know whether my experience of red is the same as another red within me, okay? Left side and right side, exactly. But if this and everything else is the same as this and then everything else, then it's very difficult to understand whether it cannot be the same, different between this and this. That's the sort of the idea. Its application to across individual, across experience is more complicated, and it requires more careful treatment of this idea, but this is a rough idea of Yoneda-Renmo. Okay. All right, and then I have some questions, but I'll again skip here for now. Why? Yeah, all right. So the yes, Z-Fun's question. So by classical psychophysics, what you mean is probably the threshold measurement, let's say, or point of the okay, so right. So there's a lot of issues with that, and then I can talk more than hours. But the upshot is that the Weaver, the Fechner, and what's Fechner, right? I mean, Alex and I have been writing this, review article, but this founding father of the psychophysicist, Fechner, thought that, at least the starting point of this, psycho, mental to physics bridge should start from this minimally, discriminable kind of units of the experience. That's called a just noticeable difference, right? JND. And then their hope is that by identifying this, then you can build it as an atom, and then build up all the complex kind of experience. That was their hope initially, but they also probably had from the beginning, they know that it wouldn't work actually. But most of the psychophysics is still doing this, measuring this, just noticeable difference to explain everything, hopefully, right? But in the case of color, it's just impossible. What that means that, let's say red and slight red is very small, very small difference, but the red and also purple is already very different. And then red and green is already different. How can you actually predict this local thing to this global thing? Is very, very difficult. And then many people have tried to do that. And then basically the upshot is that you cannot reconstruct a big color space based on the global rating of the similarity. And red and purple is already kind of telling, right? The wavelength wise, red is very close to the infrared, and the purple is very close to the ultraviolet. But in the Qualia space, it's very similar. But how do you make this kind of just noticeable difference into red to something invisible and then coming back to here, right? Okay. So about the intrinsic property, I'll just be brief. This is a question, and some traditional philosophy I recognize define or operationalize the term qualia as something that is intrinsic, that cannot be related. Okay, but as Chalmers also say, we also use this quote, right, in our reply to some reviewer, that it is just one type of the sort of a hypothesis. Nobody knows whether there exists actually any kind of qualia or quality of the experience that can never possibly, relate it to anything else. And we did this kind of exercise last year as well. Nobody came up with any, kind of example empirically. So I don't know. But then another one, relational memory, is a thought experiment that Nicolo Negro, who was a participant in the last year, came up. Basically what he says that if you, so he's kind of confusing here about epistemology and ontology, I think. If Mary knows all facts about the relationship, but have never experienced a yellow here. And then when I met Crystal first time, this is yellow. And then do I learn something new? That's a question. Okay. But I won't go into the detail, or I will reveal it in that afternoon. But think about it, whether this is actually making sense, or what's your opinion about this? So the Yoneda perspective is that my sense is that the redness of red you have is structured and also determined through its counterfactual relationship with other colors. So now from going from the more mathematical or theoretical into empirical, so it's relatively quick. How can we use this kind of idea into the actual research? So one thing is the color quality at the peripheral vision. I think probably even Christoph made this kind of point in the textbook or lecture, but this is the distribution of rods and cones in the retina. This is a relatively famous thing you see in every vision textbook. Okay, and then what it means is that basically the cones responsible for color vision is very high in density around the fovea, and it drops very sharply by the time of the 5 degree from the fixation point. Okay, and then the rod dominates and it decreases. So from here, people like Dennett and also Dehen and many other people, I think Nick, I forgot, but he who got a very prestigious book, Nick Chater, cognitive scientist, who got a Romero Hart Prize or something like that, wrote a recent book saying that this is the facts. Therefore, you are actually not experiencing color here. And this is the reason why you should not do this kind of first-person perspective kind of research or Qualia first research, right? And this is multiple times, said that. And it's even still there in the textbook, I think. But the fact is that if you have a thumbnail around this big, this is roughly 1 degree of visual angle. So this means that by the time here, your cone is already dropped into the level of really, really low density. So that means that while you're fixating here, can you not see this or that as a colorful? It's weird, right? So we wanted to do this kind of setup as a registered report. So we have a good, hypothesis from philosopher and another good hypothesis from the actual experience. Which one wins total? And applying this Yoneda lemma idea. What we did was to present, 2-color patch in a random location with very short duration so that you cannot move your eyes. Okay, like here, and then rate the similarity from 0 to 7. And then it looks like this. Yes. So this one was very similar. So 1, I would say, and this is very different. So maybe 6, and at the periphery. And that's very similar. Fovea and periphery, 0 to me. That's kind of similar, maybe 4, right? So you know what I'm talking about. And then this happens at the location where you can't expect, you can't memorize, you can't fill in basically, because you can't have time to make an eye movements. But what happened using this, kind of a virtual reality, very wide field, view, is that comparing the center to center patch, you get this kind of similarity rating matrix. And the white is the most similar, the 120 or something, very somewhere here. But again, it's unpredictable location, okay? And then the periphery, similarity structure, almost the same. And the result doesn't actually change much when this is just for the visualization to have a very big one. But as long as you can actually feel that there was something, then the result is the same. Curiously, some people actually do not actually even see things. So there are probably something about maybe Michael Cohen or Dennett. They may not actually have the peripheral vision actually. Seriously. I mean, yeah, that's what it is. So here, without any kind of an eye movement, and this is also registered report. Reviewer agreed that this is worth doing, and we did it only after acceptance of this proposal, and then we got this result. And then if you project this into so-called multidimensional scaling, then we get almost the same kind of location for the peripheral and also central, except for this, purple. We don't know exactly whether this is actually, something or worth looking at or not, but that's this, okay? So that's the first empirical study. So this is within subject, intra-subject similarity, and also simultaneous judgment. So it's also intra-phenomenal similarity. Okay, I now talk about intra or inter-phenomenal similarity because this is going to become very important in relation to IIT. IIT so far talks only about intra-phenomenal and also intra-subjective, within subject, within phenomenal kind of relationship or structure. But this experimental kind of paradigm can extend into not only intra-subject but intra-phenomenal, but inter-relational experiential kind of similarity, right? Because I can show red now, and then red now, and then I can give a similarity rating, right? And if IIT says that each moment of the TPM is so different in the brain, you have zero consistent experience from moment to moment, then having this similarity structure from within intra-phenomenal experience versus inter-phenomenal experience should be different, right? Well, let's see how it goes. So now this is about also inter-subjective comparison. So now here, probably not so many people have had kids. How many people had kids? Okay, maybe a minority of the people. You may have, if you are very careful and curious about their color experience, if you ask them, they are most of the time confused about color terms, especially around 3 years old. And if you are planning to have kids, definitely test it. Around 3 years old, most of the kids are very, very confused about blue and green across culture. Not blue and green. Today this could be blue, tomorrow this could be green, or maybe in 3 minutes or something. But even other colors are also confused. So this is a color naming task. Each chip is given to kids, and then kids just said, "Oh, this is green, this is blue," and so on. So based on this, cognitive developmentalists usually thought that children's color experience is potentially very different from adults, right? But this is also based on the hypothesis called the Wolf hypothesis, Sapir-Whorf hypothesis. The language affects on your perception qualia. And the strong form of this Sapir-Whorf hypothesis is already rejected, but still many people really strongly believe that there is at least some kind of effects, right? Jeremiah, we can talk about it. But anyway, so if this is the case, children's color structure should be very different from adults, right? But it turns out it's not properly studied before. One of the reasons is that the children's response usually is kind of a bypass through the adults. So you can't really measure the reaction time or their genuine response. But we developed this iPhone app. And as you may know, the recent kids actually start touching before actually doing the mouse, indeed. And my kid, for example, he unlocked my iPhone when he was towards the end of the first year of the life. And he's very now good at gaming as well. So it's predictive, right? And then inspired by my son, we developed this kind of a device, and then they can now report the similarity really well. And then it turns out that from age 3, 3 so far that the ones that we tested the lowest, and we are going into a second year of the life as well. But 3 to 12 years old and the adults, as well as China versus Japan, there was also no difference here. And why we tested China is related to some kind of a preference hypothesis and the cultural hypothesis about color experience. Some of the Chinese people, descendant of Chinese people, would probably say that for Chinese people, red is very special and positive, right? It's very culturally, deeply ingrained, and it's. Sure. But so now some of the Japanese people can also testify that Japanese people don't usually consider red as a super positive thing, right? they probably, especially male probably don't wear red, right? I want to get this, this kind of thing in a Uniqlo, but I can't buy it. So Japanese have probably half preferred and half, not preferred kind of attitude towards the red, probably because it's too salient or maybe associates with the blood or something like that. But absolutely, adults or child or Chinese or anything doesn't have any kind of special relation to red to other things so far. Just only 9 colors. So I have another kind of question here. Yes. Right. Thanks for the clarification. Yes, that's our conclusion. Yes, Alex. Here, at least structure-wise, similarity rating-wise, we are very similar. But this is, this is a part that we need to start to be very careful, because in our case, we probably have a vague memory of how it was like in the 3 years of life, where nobody probably reported, I used to actually confuse blue and green, right? And then now suddenly I started to become aware of this kind of difference. So you can start to some extent rely on your subjective experience kind of memory. So that's why I think we can kind of apply the Yoneda lemma type kind of characterization qualia through relationship. But even if you get something like that from other entity like AI or animals, we have to be careful about this. I don't know whether that answers your question. Yes.
I was wondering, what extent this actually tells you that it's concept very well? Like, if you did that with shapes, for instance, like if I don't know, that's a good example. But if I see a square, a triangle, and a circle, those are kind of different. But maybe he's made mistakes also on that mistake. Speaking about the concept square or circle, and use them properly.
Right. Right. So we are. This is just a beginning. So we are now starting to do at least emotion, for example, presenting an emotional video 1, then 2, and then give a similarity rating. So we can get something like this for the emotional categories and so on. The hope is that some kind of complex emotion like awe, right? Or the beauty, or we probably can't show any kind of sexual material to kids, but something that only adults. Sorry, or we can't study orgasm in children, but some kind of complex emotional category and similarity matrix would be very, very weird for them. But the basic thing is probably already there from the beginning, I think. Yeah, really.
So you're looking at relations to colors of colors. Also motion, so whatever similarities. Let's all so right boy things that are compared to the same. Once you start differentiating knowledge, world, you might see this culture.
Yeah. So two things. One is that about the actual concepts of objects or something like that. If we do the same thing, we probably will get a different kind of result. I agree. And in terms of the word-word similarity experiment, Kyoko has been kind of involved. We use 10 color words and also 12 emotion words, and then ask the similarity between the words, hoping that maybe depressed people have a different kind of structure and so on. But so it's totally possible to do this kind of experiment. And yeah, that's sort of the things that I want you to discuss. What kind of experiment we can do, and so to address this kind of question. And Isabella?
Understand how they complement each other. One is about the experience.
The contradiction is this based on this physical fact of the retinal, distribution of the cone. If you predict based on this that we should not experience color, then that's inconsistent with this. That's what I'm saying, right? Because similar color structure to similar color structure, the color direction of similar graphics, same. It's a little bit more complicated than that. It's more to do with these people, that Dennett and Dehane and so on are typically confusing or not talking about the crowding, which is a bit detailed kind of concept in the visual psychophysics. But if it's not crowded, then our experience of the color is actually pretty good. So something very small like here, as long as you can see it, then you probably see blue and green and yellow and there are here. But once it's surrounded by many different colors, like this one, then you start to lose the color sensation very quickly. And now we are increasing the radius of the chain as we go further, right? Then you have zero crowding effect. And you can recover this color experience in the periphery per se. But the crowding and the qualia is kind of related, but it's not the same thing. Okay. So because the last part is highly related to Masami's talk, I'll go relatively quickly. So far, we are using very, very small subset of the stimulus, right? And like Billy's question of word and so on, it requires many more stimuli, definitely. And then also, children's structure may be also different from adults when you start to test many fine different kind of color experience. So we started to expand the space of the color into 93 times kind of matrix, which is not impossible, but it's very tedious. And so if you don't have a particular hypothesis, people usually do not measure this. And as Christoph said, many of the scientific discovery or development is highly dependent on the development of the methodology. And here we are using online experiments. And also some kind of algorithm to distribute the trials across many people and then gathering up, in a very efficient manner. So now we can do it. So this kind of experiment can be done in 1 day or less. So that's very nice right now. And also computational analysis that Masafumi has applied unsupervised structure alignment. So what we basically contrasting is a traditional method of so-called structural analysis that other people do. Usually, if you go into the neuroscience conference or something like that, this is what most of the 99% of people do, which is that you have sets of stimulus, you have another set of stimulus, and then that correspondence, or you have a goal to optimize, and then just measure the deviation from the ideal. And that's the most straightforward thing is the correlation analysis. X-axis is your color response, and the y-axis is another color response. And then if it lines up diagonally, that's the highest correlation, right? But it completely destroys the relational information, right? If you think about it. Correlation analysis doesn't care about the relation to each other. And this one, Masami's, structural approach is alignment just based on the relationship. So we first mask all the identity of the colors, and then just look at this relational, information, and then you allow the mapping to just change the relation a little bit, but only optimizing this relations of the relationship. It's a meta kind of idea. That's a category theoretical kind of idea. And if you do that, eventually you ask, is my red, you're this one, or maybe that one? I have something that you don't have, right? And then that's so dissimilarity matrix. So here, this is about 400 or 500 people's average, but Masami may talk about data from 11 individuals who did this over 10 hours each. And then structure or more probably. You collected the data. But I did the psychophysics on myself in the past, like 30 hours or something. So it's not impossible, but you definitely need some kind of prior hypothesis or expected result to do that. Anyway, so the color structure, just a three-dimensional projection, is already looking like this. And that's very different from CIE lab space or RGB space or something that many people believe. But because nobody actually measured it, I don't think this has been presented in this way before. So I think I talked with you probably, right, Stefan, yesterday. The fact that your data is consistent with the CIE lab, for example, is not the same as it will be same as a scalar similarity structure. Okay, and then what we do is that based on the grouping of 100 people, 1, 2, and another, we do this, only relations are modulated without looking at the labels, and then T1 and T2, when optimize its relation, it turns out that it's almost like identical. It's almost, not perfect in terms of label as well. But A1 and T1, it's almost, really random. What happened? Because A is a color atypical group. So online, we can already detect the color atypical people by doing the Ishihara test or some other clever psychophysical trick. And then we got one color, identified by one color, each of the color, like red, 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 red here. So it's roughly, preserving the similarity as a distance, but it's not quite, because we need at least like 7 dimension or something to encode this distance relationship. This is arbitrary. So it's a PC1, PC2, PC3. Right. Right. So let's say you can imagine this is an average of 100 people, but each person did only 300 combinations.
So each
It's color. So it's not average. It's the so multi-dimensional scaling. So if you look at one particular dot, right, this corresponds to this color, and then this to that is closer than this to that. Therefore, expected kind of similarity to this is, lower than this, and which is already strange here. And for this, this and this should be closer than this to that. That's really the limitation of the three-dimensional representation. We can't represent it in 3D. Even for distance is also, that's kind of one question we can answer. But I think that similarity is not this.
So why are those two similar looking colors so distinct?
To which one?
The ones we just pointed at, they both seem this one and this one.
Because this is the best location to preserve the relationship between all of this, especially this one. So these are close and well preserved. Right. So this multi-dimensional scaling method is not perfect. Doesn't explain 100% variance. As I said, you need 7 dimensions or something at least to explain huge amount of variance, and also even more variance can be explained by going more higher dimension.
Then perhaps the second dimension is into 3 dimensions.
That's this. Yeah.
So we have looked at the distance seems stranger between those 3 points because of the image. Because maybe like it's a bit cheap. It seems that if you look at space,
that kind of detail we can probably talk about it, but I'm just saying that you just you can't explain lots of variance with 3D. There's a lots of things that needs to be explained by additional dimension. And in the end, I probably will talk tomorrow that this dimensional kind of thinking of the qualia is just bad. I think we need to go beyond that. I don't remember, but maybe 70 or 80 or something. Do you remember? But we can probably talk about it. It's good, but it's not perfect.
It's much more than just three-dimensional.
Oh. Like this, I'm going to talk about with no, okay. Like alignment with, for example, GPT output is much better than RGB output or CIE output. So it's very different. Maybe Zifan? Or maybe I'll just close and then let's move on to the break and then go to Masami's talk. Or most likely, yes, I would say. Yeah. Or how about this? Shall we go without a break to go to Masami's talk? Because if we break, that's we need a break, right? Okay. Okay, then let's take a break. And then I'll take the question from you guys. So all the questions I already listed, so you can actually take a look for the kind of the break and also the small discussion. And in relation to IIT, this is the final slide. What we are doing is talk about characterize the Qualia structure, especially inter or intra to a volume. This here. And what IIT is doing so far at the moment of my experience, what kind of cause effect structure it is unfolded. And then it's related to probably something else. But IIT does not have right now how to measure the similarity between the experiments. Okay. So we can't really directly go from this and this. This part completely disregards the relations again. It's like a correlation analysis over. And then IIT also should have kind of causative structure, let's say different person. Then if we are sure that this person and another person is experiencing the redness the same way, that is my left to right, in this way, and then ideal structure collaboration would be to draw this commuting diagram. You can go from this way or that way and you get exactly the same result. That's the category of thinking, and that's the solution of the and that will come in maybe 10 years, 100 years, but I'm very hopeful. And my prediction has borne out, right, Alex, so far. This is, so unlike IIT, we think that assuming some kind of identity, even explanatory identity, may be not really good empirical start. Empirically, we can just focusing on the, one-way direction of explanation, which is called a functor. Just preserve functor, preserving the relation to map from one to the other and the one to the other. And then there's likely to be some kind of systematic deviation of going from there to there. And then that's called this adjunction. You can try, you know what I'm talking about, hopefully, right? But if I explain this to you and you report back what you understood to me, then I feel like, this not good, but it's okay. As long as you are good, that's the adjunction, right? But if I talk to dog and then they respond, then it's completely collapsed into bow, right? That's not a meaningful, interesting adjunction. So that's rough idea. We want to go gradually from this adjunction to isomorphism, but that isomorphism may not be even ontologically obtained for several reasons related to also the quantum kind of quantum-like idea that we talk about tomorrow. But I think that's our hypothesis. Thank you.